So just to give you a sense of the complexity of the code base, it's 14,000 lines of Python. So the reason that it complex is basically a lot of agents and a lot of fault tolerance for these agents. Every point where you insert an agent into the system, you need to handle the case that it failed. There are multiple ways to do fault tolerance. One is to ask a human, another one is to automatically retry, and then there's task-specific ways to do it. It's super dependent on the situation. But the main point is you have to have fault tolerance for every agent. And you have to build that in from the beginning.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Shreya Shankar. Shreya is a PhD student at UC Berkeley. Before we get going, be sure to hit that subscribe button wherever you're listening to today's show. Shreya, welcome to the podcast.
Thanks, Sam, for having me. I'm excited to be here.
I'm excited for the conversation as well. We're going to be digging into your research and in particular, the project that you just released yesterday, DocETL. But you've got tons of experience working with LLMs and LLM evaluation, and I'm sure we'll touch on those topics as well. To get us started, I'd love to have you share a little bit about your background.
Yeah, so I'm a PhD student, fourth year at UC Berkeley. I'm interested broadly in interactive and intelligent data processing, and this is inherently multidisciplinary. I'm very excited about data management, data processing. How do we unlock insights from so much data that we have in this world? I'm interested in AI because I think that AI provides all of these capabilities to do analysis that we just never had before. And I'm interested in HCI when humans have to work with these inherently unreliable systems. What are the right interfaces to help humans gain trust and iterate quickly on the analysis tasks that they want to do? So it's such an exciting time, I think, to be doing research in these areas. Before my PhD, I was an ML engineer at a startup. Did a lot of structured data, tabular data, machine learning, a lot of XGBoost. And then before that, I was at Stanford doing, learning to code, I guess. That's doing my undergrad in CS.
Now, your research area or the areas of interest you described are pretty broad. Like, how have you structured that into a research program for your PhD?
Yeah, that's a great question. My primary area of research is in the data management community. I was drawn to it actually because my job as an ML engineer, I found 99% of my problems were data problems. Maybe my data was not clean, the training wasn't good, but it was because the data was bad. The inference wasn't good, but it was because of the data was bad. And I was learning so much about data quality. I was learning so much about large-scale data engineering, like how do you build these robust ETL pipelines, that I thought, do people do research in this? Because it's such a hard job and nobody can do this well. If you go to industry meetups, everyone has these problems. And yeah, no better way to learn, I guess, than do a PhD at Berkeley Database Group. And kind of along the way, I think I've always been interested in AI and machine learning, especially coming from Stanford. And along the way, I really picked up this interest in HCI, especially with generative AI and large language models. These days are fundamentally changing kind of how we interact with content and data and produce content. And the experiences just they feel so like day zero, right? We're so early and it doesn't feel great. Like I'm writing something with AI, but I open a chat to tell the AI to write something, but I'm writing it and it doesn't feel right. The vibes are completely off. I mean, that's what's exciting to me about it.
It still amazes me that the thing that cracked this all open was slapping a chat interface on top of an LLM. That's nuts.
Absolutely. Absolutely. It's such a fascinating thing. And if you think about the marketing behind it too, like TikTok, ChatGPT videos were all over TikTok in 2023. And I'm sure that contributed to this. And it was always things like, oh, here's this app that'll do your homework for you. And you'd have these high school students who are write me an essay on Napoleon or whatever. And did that blow it all up for us? I don't know.
And so Someone who spends time thinking about interfaces and interactivity in HCI, like, what's your kind of glimpse into the post, chat dialogue oriented interface to these types of systems? How do you think about where that's all going?
I think we're inventing new interaction paradigms with these AI models. At least like in HCI research and literature, people kind of did work on these physical devices that came out. So when computers came out, people did research on cursors, on inputs, on text boxes. Like these were the primitives that kind of defined how we build UIs. When the phone came out, people did a lot of gestural research. Like if I drag down, it will refresh the app. Like somehow we intuitively know these things. And I don't think we've like built the intuitive primitives for interacting with ML models, like the inherent non-determinism of it. Like how do you edit content indirectly, but still have that direct feeling that you edited content? That's just a problem I've been thinking about all of today. We're building an interface for people to interactively write data processing pipelines with an LLM. Like writing in a chat, extract all of these fields from a document, and then it synthesizes the code, and then you run it. It just doesn't feel right. It's not very iteratable, especially when you look at the output and you say, "Oh, you missed these fields." Are you going to type in the chat, "You missed these fields"?
Yeah. Yeah.
Like that seems. It's I don't know. It seems such a far cry from what we could do. Unfortunately, I don't have a better answer, but we're definitely exploring these kinds of questions.
Yeah, I remember having the feeling, I think it was in the context of like I was at the Google Next conference and they rolled out their like enterprise agentic vision, which kind of looked like, all of their old application silos for sales and marketing and customer service were replaced with like agents now. Um, and it was interesting, but I also remember having the feeling that like dialog boxes are not the right interface for everything. And if, all enterprise software suddenly became like a chat box and not like these interfaces that we've refined over time, like that seems like a step back. And it sounds like you agree with that.
I agree with that. I think it's difficult, right? It, chat is like universal, so maybe that's why people use it. And you kind of do need some sort of domain specific things. But one thing I really like and I think about is now Notion AI actually did this, but the ability to highlight content and then edit it, but edit it through an AI. So you highlight the content you want edited and you instruct in the text box how to change it, and the AI changes it. That seems so much closer to direct manipulation feelings.
Yeah, there's something about like I don't know, I'm thinking about state as like a concept and wanting the LLM to be able to like directly manipulate some state, but also the human to have whatever the native way of manipulating that state is, you want them to have that also.
Absolutely. Absolutely. That's 100% the core of it. And then there's the added dimension of what's the context that you need to manipulate the state. What we see in our vision, everything that you're seeing on the screen is the context that you're using, plus like stuff in your head you haven't told anybody. But LLM can't read your mind, and it can't possibly have all the context on your computer. So, like, what's the right way to indicate or at least shape the context here? I think is so hard.
So, a lot of this speaks to some work that you're doing around DocETL. We kind of jumped ahead into the future. Let's pull it back and talk a little bit about DocETL. And maybe a good place to start is kind of the way you think about the problem that you are solving with this project and kind of how it came about.
Great question. DocETL is a declarative framework for building and optimizing LLM-powered data processing pipelines. So that's a lot of words. I'm going to illustrate this with an example use case here actually at Berkeley. So there's a big project going on that's interdisciplinary, spanning the lab that I'm part of, the EPIC lab, the Berkeley School of Journalism, and even the state of California. The state of California is funding it. But the goal is to collect data from all the police districts in the state and identify patterns of officer misconduct. So that can be kind of excessive use of force, that can be lying, manipulation, lots of different definitions of misconduct, and see if there are repeat offenders. California has this problem of sending an officer from district to district, even if they might have done something bad, whatever, wipe the slate clean, send them to the next district. So all of this data from the police departments is fully unstructured. And the way that they would solve this problem is to hire interns to annotate this data, things that could possibly be police misconduct, create a big knowledge graph. The data can be, thousands of pages long. It can span multiple cases, multiple officers, all sorts of things. So the question really is, how can we program LLMs to help solve this problem for us? What are the programming constructs that we need here? What does a data processing DSL look like here? And how do we make sure it's reliable? Right? It's something to say, to submit your 100-page PDF to ChatGPT and ask for officer misconduct. Is it right? Probably not. It's going to miss officers. It's going to get misconduct wrong. It's going to hallucinate things. The stakes are too high here for this kind of task. So DocETL is really, the goal is to solve these kinds of data processing tasks. Users simply have to specify prompts for operations at a high level. We have different types of operations, like a map operation, a reduce operation, very similar to kind of common data processing frameworks. But they're powered by prompts. So you just specify the prompt, and then DocETL will rewrite these prompts, chunk up the data, chunk up the task into smaller units that can be executed accurately by the LLM, and then stitch the results together.
And the implication of ETL being that this is something that happens as kind of a batch operation as opposed to an interactive, a la the dialogue box we were talking about earlier. You are,
The ETL, it's a pattern of, writing a pipeline to analyze a large amount of data. Now, it has to be interactive because what we found through preliminary studies, and I've even written about this in some of our validation work, is that humans have no idea how to write the prompt until they see the initial output. They have to see what the LLM came up with the first time that they wrote the prompt and then say, oh, actually, they changed the task. They redefine misconduct. They redefine what it means to use excessive force. And so it has to be interactive in this way. The question becomes, how do you allow them to iterate fast, not how do you completely remove them out of the loop?
And you mentioned the DSL is the idea that the LLM is exclusively used to create this artifact that defines some backend processing, or are LLMs also used in the backend processing for, things like classification, text extraction, what have you? Those aren't clearly not mutually exclusive, but I just want to make sure we understand where LLMs come into play.
LLMs come into play in both the execution of the operators. So I have the LLM do the extraction from the document, as well as orchestrating. So LLM agents determine, hey, this input document is too long. Let's figure out the right chunk size to process this subtask to get good accuracy. So that's what we call the optimization stage. You define your pipeline at a high level. We optimize it, which means break it down into units that we know the LLM can do well, based on automatic validation and so forth. And then you can run the optimized pipeline.
This is maybe more of an engineering question, but with these ETL systems, often one of the biggest challenges is that everybody wants a different connector to either their data source or data sync. Have you started dealing with all that? Where is all the data coming from and going here?
Yeah, it's such a research prototype right now. I think people just have PDFs and folders. A lot of people don't even put unstructured data in the data warehouse because it's designed for structured data. Unstructured data lives in document clouds in JSONs. And I totally see once in the future we're certainly going to have to connect directly with the data warehouse and so forth. But right now, I think it's so novel to kind of run these kinds of analysis tasks with LLMs that doing it in a folder is a lot.
And so is the user experience, you point this thing at your folder, it slurps up all your documents, and then you're interactively kind of building out this processing DSL. Like, do you see like a spreadsheet kind of interface, or do you get like, how does the user, as part of that interactivity, how does the user see the results of what they are trying to do from a document processing perspective?
Great question. Right now, we don't have an interface. We're building it. The user kind of writes a YAML file that specifies the operations. Each operation has a type and a prompt. So that part you kind of just do in your text editor, and there's a command to optimize the pipeline and a command to run a pipeline. But the future we see is we're going to have a UI. We're building the UI. I like the idea of a spreadsheet, but people just get very turned off by large documents and spreadsheets. It's not the right way to visualize it. So we're exploring, how do you create one operation at a time, run that operation, look at the outputs for a sample, and then have that inform your next specification of that operation. Once you're feeling good about that operation, moving on to the next operation. A lot of these analysis tests across domains follow a MapReduce like pattern. For each document, map it to a set of one or more topics, where topics can be misconduct instances, or pretty much like anything domain specific. Then canonicalize those topics, because LLMs have variability. They might extract names differently, so forth. Then group by the topic and apply some summary.
And is summary like a textual summary, or like an aggregate in the database sense?
A summary is simply an aggregation. You take in many inputs, you output one thing. So it's an LLM powered aggregation. So it's for anything your prompt. You can write anything in your prompt. You have access to all the inputs and you return one thing. So summaries are just a natural way to think about aggregating a lot of text. But you could certainly imagine, find the most common type of misconduct. That could be a prompt. Find anomalies. Find officers who committed the most misconduct. Like all of these, it's very flexible in that sense. But yeah, a bunch of pipelines follow this MapReduce like pattern across domains.
Are there any particular models or types of models that you have built this around? Did you emphasize open weights models like Llama, or did you start with the OpenAI models? How have you thought about model support?
Good question. We started with OpenAI models because I think they were just the first to support tool calling. And we do support tool calling in our map operations. But I mean, any LLM can be used. I do think that there's a big need for supporting open source models for sure, especially when you're dealing with like sensitive data in the medical domain. I find it very fascinating. Some people say like, "Oh, we're fine using OpenAI. We're fine using Azure. We're already on Azure, so we're going to use Azure." And then other people will say like, "No, we absolutely have to use Mistral." So I don't know, all sorts of. I think we need to support both.
Now, extracting data / text from a PDF, sounds very simple when you say it quickly, but that can be arbitrarily complex, and there's lots of maybe adjacent projects that are doing things like using vision-based tools to identify regions in the PDF and dealing with the visual structure of the PDF or the text structure of the PDF. Are you dealing with any of that, or is
Not
that
yet.
outside of
We
scope for
want
you?
to. We just naively run OCR and take like Azure OCR tools and then take that as input. The kinds of tests that we think about, like the kinds of extraction tests we think about, are really like intelligent extraction. Like you need to have context or domain knowledge to kind of know, for example, extract all medications from this document. You need to know what a medication is. to be able to extract it. It's not extract all instances of Tylenol. Like that, you can kind of figure out some other way. But these kinds of, and that's just a simple intelligent extraction task. Like the officer misconduct, that one's a really tough one. Like LLMs can do it well when prompted correctly. Sometimes, the data might have a lot of misconduct in it. And then you need to look at smaller chunks at a time to extract all instances of misconduct. If it's a very large document and it's like a needle in a haystack problem, there's only one instance of misconduct in there, the LLM might get that automatically. Right? So it's very data specific and very task or prompt specific. And these are the kinds of interactions that people who are writing pipelines, whether they are journalists or they are, expert AI ML engineers, everybody has to do experimentation to figure out what's the best way to make these reliable. To me, that's like the problem of an optimizer. Users should be empowered to see outputs, make change to prompt, and then everything else is the job of a system to help them achieve that.
Are there things that this particular problem has shown you about writing prompts that you haven't come across, generically or with other problems?
Yeah. The more you're able to have users look at the intermediate outputs, say the extracted cases of misconduct for a sample of docs, the more complex the prompts get. When people, and that thing is very fascinating to me because I think there's a lot of work in, automated prompt engineering, optimization, and so forth that really puts the human out of the loop.
DSPY and like.
I really like the idea of DSPy, like making it easy to declaratively specify things, but not having a human in the loop is you have to have a human in the loop here, because if a human is seeing the intermediate and would do something differently than what the system will do, then already you're not aligned with the intent anymore. So that's been surprising to me. Like the more humans iterate, the more it diverges from what the system actually would do if you took them out of the loop.
Is there a particular example of that you've seen that comes to mind?
Yeah. So in this example we talk about in our eval-gen paper, which we'll be presenting in a couple of weeks at WIST. We've been doing research on how do we have human-guided, AI-assisted evaluation of outputs. And something that's interesting is that humans look at more and more outputs and change their mind about what makes a good output based on the LLM's behavior. They might say something like, don't specify a hashtag in the output, if they're mining tweets. But then later on, they might realize actually they do want important hashtags in the outputs. And this is not something an automated eval assistant would ever be able to ascertain. The human looked at it and changed their mind about what the task is, which I thought was very interesting. A similar case of this was somebody was using DocETL to mine reviews for a particular course to see, what are common themes for why people signed up for this class, and so forth. And when they saw the intermediate outputs where they were mapping reviews to themes, they were like, this is way too many themes. I don't want this many themes. But if you ask an LLM to kind of refine that prompt further, the LLM won't go in that direction of reducing the number of themes. It won't know to, right? So it's always a question of like, how do you get the human to like steer it really, really easily and without too much overhead.
What did you come up with in that paper as, some ideas for how to do this? It sounds like just letting the human kind of have at it in their little chat box and, bang their head against the problem. Is there more to it than that, or have you come up with some interesting approaches?
Interestingly, that paper, so we built an interface that allows humans to grade outputs as good or bad, and then uses an LLM to find implementation, like predict whether the human will grade it as good or bad. And then in the study, in the user study, we observed this kind of criteria drift. So it's I don't have a solution for that because
Got it.
it kind of emerged as part of the study.
Yeah.
The other thing that I think we were uniquely able to observe that because our interface supported really fast iteration. If we're able to show a human 100 outputs and get their feedback on it in the span of a minute, like we can observe things in that kind of study than say if you ask a human to only grade 3 things and in between each time you ask them, it takes a really long time.
So speaking more broadly about evaluation, like if you've got the LLM in this planning loop and you're trying to build out an evaluate, first of all, what does evaluation even mean in the context of data processing? Is that well defined or is that to be defined?
No.
And then once you stick an LLM in there, like how does that change the way you need to think about evaluation?
Yeah. Good questions. So first I'll explain kind of how DocETL's optimizer architecture works. The user specifies a high-level pipeline, and then we have generation agents that take the operator and rewrite the operator into a sub-pipeline. So you could imagine writing a map operation, which just one-to-one document to output, into its own little pipeline that chunks up the document, applies a map to each chunk, and then aggregates the results. That's one type of rewrite. There are many types of rewrites. You could do a chain of thought like rewrite, where you break up that task into an intermediate task that's helpful, and then the task. And that could be arbitrarily long. Or if this is very common, people want to extract 40 fields of information from documents. You could break that up into 10 operations, each extracting 4 fields. Very simple. So you can imagine there's like all this number of rewrites that we have an LLM come up with, and this gives us so many candidate plans. Then we can run these pipelines on samples.
Is the LLM coming up with these candidate plans in natural language or DSL domain?
In it's very guided. So we have a DSL of these operators, and we go through all of our predefined rewrite rules, and we ask the LLM to come up with prompts for the new operators in those rewrite rules. And we have no idea how well it's going to do until we try it on a sample.
But it's kind of a constrained domain that it's working in.
Yep, exactly. And it's nice because this paradigm is very flexible across domains. Like you can do this for processing legal documents. You could try a bunch of different chunk sizes, or you could try a bunch of different task decompositions. And the agents will kind of come up with it. They'll come up with the prompt. We'll try a number of chunk sizes. Like here we have 100 plans. Like great. All of varying accuracy. Who is going to know? How is anyone going to know how well the candidate plan will do? And this is where the evaluation then comes in. If we run all of these 100 pipelines on a small sample of data, which outputs are the best? So in the police misconduct case, or any case, first we synthesize a task-specific validation prompt. So in the police misconduct case, you might have, are all instances of misconduct extracted? So assessing recall. For each instance of misconduct, can you actually trace it back to the source document? If every extracted instance actually misconduct, like does it satisfy use of force, so forth. So we'll have like kind of 3 bullets that are very specific to the task. And then we'll have the LLM evaluate the planned outputs with respect to that. So everything hinges on having a good validation prompt and a good kind of ranking algorithm here. So we ideally we would do pairwise comparisons. Like that's pretty well known in the ML literature. If you want to find the best model or find the best plan, you compare outputs side by side. But that doesn't scale when you have hundreds of candidate plans. So we kind of do a coarse-grained rating for each one, and then take the top K plans and then do pairwise comparisons there. So if your validator prompt is good, this will give you, if you trust your validator prompt, this will give you the best plan. And in practice, the validator prompt is a really good first start. It gets precision, it gets recall, it gets accuracy. Where it fails is in these, like, when the human wants something that is a little bit ambiguous and can vary from human to human. Like maybe you want to extract coarser grained themes from your product reviews than I might want. I might want hundreds of themes and summaries of all the quotes around that, and you might only want 2 themes. So like that's where the knobs have to change on validation, and I think that's also where you get an interesting UI problem of how you can get the human to guide that.
And so is that evaluation framework, let's say, of precision recall accuracy, is that kind of a hard-coded aspect of DocETL, or is that an example of an evaluation regime that a user could specify somehow?
It's not hard-coded by DocETL. We use an agent to come up with that validator prompt specific to the task. And the agent's prompt is, you're doing a data processing task. Here are common data processing tasks. Synthesize an instruction related to precision. Synthesize an instruction related to recall. Come up with 1 or 2 other task-specific instructions that relate to the quality of the output. And then that's like the validator prompt.
Got it. And then in talking about this evaluation stuff, the whole concept of agent and agentic has come up a few times. Kind of zoom back out and talk about the system from that perspective. Like, did you, is it a multi-agent? It sounds a little bit like a multi-agent kind of thing. Is it? And if so, like, what are the main agents? Like, are they orchestrated from the ground up? Like, did you write the orchestration, or are you using some open source thing? Like, what have you learned about building agentic systems, and what can we learn, from the way that you've done this?
Oh man, agentic systems are so hard to build. We started building this prior to any of the frameworks that are out now. So to just to give you a sense of the complexity of the code base, it's all in Python just because it's easy to work with LLMs in Python, but it's just disgusting to build a system in Python. Anyways, it's 14,000 lines of Python, and which I think is like a pretty huge Python-based system compared to other code bases. So the reason that it's complex is basically a lot of agents and a lot of fault tolerance for these agents. Like every point where you insert an agent into the system, like you need to handle the case that it failed. And one way to handle it is to surface it to the user, right? So already we have like an interactive system where we like somehow are passing that context everywhere that will stop the console and prompt the user, if that's one way you want to escape from the failure mode. For all agents, we can't do that, right? That might just be too much effort. There are multiple ways to do fault tolerance. One is to ask a human, another one is to automatically retry, and then there's task-specific ways to do it. If this is not critical, right? If this is just one type of we have 13 different logical rewrite rules that we could apply to operators. If this is simply one of those 13, like maybe it's okay to toss this guy out, and we'll consider the other 12, right? So a lot of it is very it's super dependent on the situation. But the main point is like you have to have fault tolerance for every agent, and you have to build that in from the beginning. I see so many people building their agents and then like not thinking about fault tolerance the first time they build it, and then like at some point it's going to break. But then there's so much complexity into like trying to recover that. Yeah, so I think maybe that's the biggest lesson, not really framework specific. Another thing is really constraining the domain of the agents. So all of the agents that we write output like structured outputs. And the structured outputs are no more than 2 things because agents just cannot do too many things at once. And they're always like new prompt or like yes or no, like should I do this? Rather than have an LLM immediately synthesize a new operation, we always ask it, given this data, given this task, is it a good idea to make this new operation, to decompose in this way? And then if it says yes, we ask for the prompt rather than one step. Is it a good idea? If so, give me the prompt. Like that's a little bit much to expect out of one LLM call. So a lot of just really unit decompositions. This itself kind of creates like there being 100 agents, 100 or more agents in the database, in the code base. But from the perspective of like, what do these agents do? Like there's really only two types of agents, like validator agents who do validator type tests, and then generate agents that rewrite pipeline in some way. So,
and if you had to guess at how much of your code base was, essentially kind of agent orchestration infrastructure versus agent behavior, prompt oriented, like business logic-y kind of stuff? Like, do you have a sense for what that might look like?
I don't think there's too much prompts for the agents, to be honest. The prompts are pretty small. At best, we have like one example per agent. A lot of the code is really in the logic of the operators itself. Like, how do you execute operators fast? I've only talked about logical optimizations of pipelines where I rewrite pipelines to be different or to be logically equivalent. But there's also kind of efficiency
like performance
based.
optimization.
Yeah, performance optimizations that there's a lot of code for. Like,
got it. So I kind of split that up implicitly in like two levels, but there's multiple levels. And I guess that at the heart of the question was like, do you think you wrote the essential, wrote like a crew AI or something like of that breadth? Like, did you write a lot of code just to do low level agent orchestration, or is it mostly in what I'm now thinking of as like a middle tier of like managing the business logic specific to your app?
yeah, good question. I have one LLM agent class that does it has some logging and it has a wrapper around whatever LLM that I want. And then anytime I want to invoke the agent, I instantiate this object and I specify the agent prompt as well as the schema. And then I specify like what to do on like
How
fault
many
tolerance
retries
policy.
and that kind of stuff. Yeah.
Or like
Yeah.
the service
No, that's
news.
awesome. I mean,
It's
I,
really simple.
had a lot of these conversations about the agent frameworks, and often there's this tension between like using some off the shelf thing, but then like you have hidden complexity that you can't really see, and when it comes down to it, in many cases the agenticness isn't all that complex. It's all the stuff that you want to do with the agents, and it sounds like that's where you've ended up.
It's really the fault tolerance. If I had to copy paste that code everywhere, I'm thinking about how like somebody else might build this and run into an issue. Like they would write a bunch of if else statements around every single agent call, and like that will really blow up the complexity of the data of the code base. But if you just centralize that logic and like have specified policies, I think it's really not that hard. And now that I think about it, this LLM agent class that I have is not in its own file. There's other code in that file too.
When we talk about ML systems, like we're often talking about benchmarks and that kind of thing. Is there any concept of a benchmark for like these data processing pipelines?
I'm baited. You baited me. No, nobody's built a good benchmark. We really should build one. We've been talking about it here. And I think it's partly because it takes a data person to know challenges of data processing. And there's just very few data people who are also very well versed in kind of generative AI right now. I think the benchmark, the whole agenda in the ML research community has been to focus on a specific kind of task, like reasoning-based tasks, or really hard math problems, or really hard coding problems, which are obviously very hard, but it's not the same kind of hardness as a data processing task. Like You could a task where you could hire college interns to annotate the data, but it would take them 100 hours. And they have to be college interns. They can't be 5-year-olds. They don't have to be Olympiad gold medalists, but they require like a base level of intelligence. Um, these are hard tasks for LLMs to do. They just get tripped up with so much context. Um, and a lot of these math problems, coding problems are not that long. They're like a paragraph long. But the more we only focus on those problems, the less we're able to do complex reasoning over data.
I was just going to ask, do the reasoning oriented challenges not quite get you there? Like, is the core challenge that, or the core aspect of an LLM that you're relying on to build these pipelines, is it reasoning, or is it more narrow than that you would want a separate benchmark? Or how would you focus a separate benchmark on this problem is maybe a better way to ask the question.
Yeah, good question. The first thing is maybe like, why are data problems different? And I think the way that you use attention. So like all these transformer models are using attention. The way that we use attention for like solving coding problems is different from the way that we use attention for solving data processing tasks. Like there's so much attention that you need to like maintain throughout the entire context. And you also need to take actions. You basically need to read the whole book if you're feeding in a book as an input. And at every point you're reading, you need to be able to make some reasoning like decision. This is a different challenge. This is not a needle in a haystack problem. Like if you're doing a needle in a haystack task, it's kind of like an anomaly detection task. Like you're kind of just like looking along and you're like spiking whenever you see the pattern that you're supposed to have. And then you're done. And you know you're expected to spike a few times. You're not going to spike twice in a row, sort of thing. But data tests are different. Like identifying misconduct requires, like, if you're in the middle of a transcript between a police officer and a suspect, and they're saying he said, she said, he said, she said, and the officer name is 10 paragraphs ago, right? Like this is not like a attention problem that the LLMs have been trained well to do. I think the benchmarks just don't have it. Yeah, so in that sense, I think like data processing requires its own set of benchmarks, where the tasks, I think ideally it's not specific to a single LLM call. That's another thing. The LLM benchmarks are focused on what can you do with an LLM call, or a loop of LLM calls, but like the input is fixed. These data processing benchmarks should allow for flexibility in kind of how you decompose the data, how you orchestrate the LLM calls. That's like a departure from traditional benchmarks. Another thing is in data processing, you can have like infinitely many correct answers. So how do you, and you have subjective correct answers. You might want to do theme extraction and have more themes. Or I might want fewer themes. And a benchmark should have 2 flavors of that theme extraction task. And simply based on the flavor, your system should be able to do it correctly. These are just the kinds of thoughts we've been having in terms of like what makes data processing different.
Have you explored any of the state-space models or long context LLMs as a way to try to address at least that reliance on attention and locality that you referenced?
We should. I know that they're getting better and better. We should definitely look into it. It's been on my mind.
In terms of future directions, you already mentioned that one of the areas that you're focused on is building interfaces, and we spent a little bit of time up front talking about that. Where else do you see this going?
Yeah, we needed to build a benchmark for data processing. That's one big thing. Interfaces, of course. I think there's a lot we can do in optimizer reliability, like the agentic reliability. We do a lot of fallback to asking. There's certain kinds of rewrite rules that agents are bad at determining whether they're appropriate in the situation. An example of this is chain of thought, like decomposition. If you have a task, technically And you can come up with a chain of thought decomposition, or you can come up with any chain of thought decomposition for any task. But the question is like, is this a good chain of thought decomposition, or is it necessary? LLM agents are really bad knowing whether a chain of thought decomposition is necessary or not. So we do, if it recommends one, we ask a user like to validate whether they want to explore this plan further. And I think like decisions where we need to query the human there are just like a matter of like, maybe our agents aren't very good. We should improve that.
Along those lines, have you looked at like the O1 series of models, these more kind of reasoning oriented models?
Yeah, we're thinking about it now. I mean, it just came out, so
yeah,
definitely. Yeah, it's not very interactive. I think that's my thing with O1. I'm sure somebody will come up with a O1 that actually
from a latency perspective, or introspection into the chain of thought and the reasoning process.
Both. Like the worst thing from a user experience is to like wait 50 seconds for like something that feels like it shouldn't take 50 seconds. So, and then like to also have no ability to like see why it took 50 seconds. So I think we might wait for more open model to kind of be trained on this chain of thought stuff. Yeah, but kind of there's that, and then there's a bunch of interesting ideas of like we've come up. The paper will come out later this week, but we've come up with these rewrite rules for data processing pipelines, and I think there are more. I think there are more in terms of performance and efficiency optimizations. We can do rewrite rules there.
Well, Shreya, thanks so much for jumping on and sharing a bit about what you're working on with DocETL. I think is it DocETL.com? Is that where folks can find out, or do they have to search for it?
I can't believe I got the URL. I just looked it up. It was $20 or like $18.
I just looked at it and I was like, wow, does that really exist?
Yeah. I was like, cool. Yeah.
That's awesome.
And then someone commented, why isn't it docetl.org? And in my mind, I was like, because I could get docetl.com. That's why. Just because it could.
Awesome.
Yeah. Cool. Thanks for having me. This was fun. I talked your ear off, but...
No, this was great.
Yeah.
This was great. Thank you.